First, to answer part A1, remember that frictional forces occur when there's a tendency for relative motion between two surfaces. So what we have here is block B, which is trying to accelerate towards the right since it is experiencing a rightward push of 28.4 newtons. So there's tendency for relative motion between the top surface of block B and the bottom surface of block A. Since there's a tendency for relative motion, there's going to be frictional forces between the two surfaces. And so this is how we are going to answer part A1. To answer part A2, since the direction of friction is always such as to oppose the relative motion, in our case here, the tendency is for block B to go ahead of block A. To oppose this tendency, B is going to push A rightward and A is going to pull B leftward. And this is how we answer part A2. It's interesting to note that if block A and B are totally smooth, then what's going to happen is just B is going to race ahead, while A, since there's no frictional pull, it will just stay put there. It will not move at all. I hope it's clear to everyone that it's a misconception to think that friction always opposes motion. No, that's not true. You can see here quite clearly, friction is the cause of motion of block A. What friction opposes is relative motion, not motion. But in opposing relative motion between block A and B, it actually causes the motion of block A. Quite funny, huh? Now moving on to part B. In part B, we have to calculate the contact force between B and C. So again, the tendency is for block B to race ahead of block C. So block C is going to try to pull block B back. So this is the force that block C exerts on block B. It's going to be leftward. That of course means that block B is going to push block C rightward. Again, these are action and reaction pair. Now what we're going to do is to apply Newton's second law on block A as a single mass and then on block B as a single mass. Applying Newton's second law on block A as a single mass, then we realize that it only experiences one external force, which is B's push on A, FBA. So FBA can be equated to block A's mass times its acceleration, and so that tells us that FBA is 10.7 Newton. Next, we apply Newton's second law on block B. Block B is going to experience three external forces, the 28.4 newtons and the two frictional forces, which are both towards the left. Since the acceleration of block B is also rightward, we are going to take the rightward 28.4 newtons minus away the leftward FAB and the leftward FCB. So writing this out here, and we can equate this to block B's mass times block B's acceleration. We have already figured out that FAB is 10.7 newtons. Actually, we figured out that FBA is 10.7 newtons, but of course FAB and FBA are action reaction pair, so they have the same magnitude. So substituting 10.7 for FAB, we continue and we work out FCB to be 2.58 newtons. In part C, we are supposed to figure out the contact force between B and C. To do that, we can either apply Newton's second law on ABC as one single mass or on block C as a single mass. Anything that involves the mass of C in the equation will help us solve for mass of C. So I've chosen to apply Newton's second law on C alone. So for block C, it experiences only one external force, which is FBC. The question stated that there's no friction between the surface and block C. So the only force acting on block C is FBC, and so that can be equated to his mass times his acceleration. And from there we obtain the mass to be 1.23 kilogram. So as always, to apply Newton's second law, you just choose your mass. After you have chosen your mass, You sum up all the forces acting on that mass, and then you equate it to its mass times its acceleration. Easy. And thank you for using XM Physics.